Start. Okay, hello everyone. Okay, so this is me, Gede Bagus as one of research in this research. The name is IoT-based anti-COVID visitor management system using Raspberry Pi Zero Y, and this is my collaboration with my lecturer at university. Name is Wirarama, and second one is Ariyan, and the third is Ahmad, and the fourth is Hidayat. We are from Department Information Engineering, University of Mataram, at Mataram, Indonesia. Okay, next slide is, this is the background why I uh, add this research. The first is temperature measure using infrared thermometer is one of the first step detecting the potential for visitor to be infecting the COVID-19 virus. And this is the measure still has potential and danger stop. Yep. Who this measure is temperature because the distance to person being measured quite close and must be through the pace. And that's the solution. Next is anti-COVID visitor management system with a physical human interface by using Internet of Things and computer vision technology. This is the automation to measure someone in automation with IoT. And the next is the text measure temperature using infrared thermometer sensor that is triggered using the ultrasonic proficiency sensor so it can run efficiently and on Raspberry Pi Zero with limited resource. The system will also be offered using Raspberry Pi, main path using system S and Raspberry Pi be the web servers too to cost effectivity. And the shop owner can monitoring people who can the potential or someone have potential COVID-19 and customer who are wrong or not wearing masks in the information system via website. Okay, this is the related system about the research. I add this Nasirne about monitoring of body temperature non-contact using IMG thermal camera. And the second is about launching this the Islamly is in Bahasa, the merancang bangun new normal COVID-19, yeah, something like that. And the third is from Saputra, and this is the Taha. Okay, about the related research is the purpose of research is more of the application algorithm to output to automation the measuring temperature and detecting mass from the entering the store. And second is the purpose research doesn't use medical equipment and focus on detecting people entering shop. The research is slow computing with Raspberry Pi Zero Y and has different focus. Namely is the purpose research is more on face detection and temperature detection. Okay, this is the system architecture design, and we have ultrasonic sensor, infrared thermometer about MLX 90614, and we have to Raspberry Pi camera, and this is the Raspberry Pi Zero Y who connect to monitor, or it can be in SSH on Linux, and the data will be transferred to internet and show to the website. Okay, this is the figure about this the ultrasonic sensor is the part happen in the sensor detect if the people who can close range if there is, and the data will be sent on Raspberry Pi. And the second part is camera detect eyes and nose via harsh cascade too, and the human face the result to send the Raspberry Pi. And the third part is the sensor detect temperature of the person, then the data sent to Raspberry Pi. The fourth part is the monitoring display result that I have been the web processed by the Raspberry Pi. And the fifth the part is Raspberry Pi processing data to temperature sensor and Pi Raspberry Pi model. The result will be wired to displaying rapid monitor, which will then to record the in JSON file and then see to the internet and the website receive the JSON file from the Raspberry Pi and display to data will be received. Okay, I get the data via HTTP for PHP and yeah, get the data, the JSON, and show to the website. And this is the hardware system. Yeah, we have ultrasonic sensor, mini breadboard, and resistor to help ultrasonic sensor connect to Raspberry Pi Zero. Yeah, but the camera Raspberry Pi camera to MLX2 and monitor SP. Yeah, we can see the hardware design, and this is the implementation about the hardware. You can see this we have ultrasonic sensor, infrared thermometer, camera, Raspberry Pi Zero, and connect to monitor, or it can be connect to SSH via terminal. Okay, this is the implementation of the software. This is the main page of the website where you can patch up to graphic who can help the owner to comparison to see of mass status and temperature status too. To image capture by Raspberry Pi camera, this website can be accessed by entering the IP address of the Raspberry Pi Zero, which connect to the same network, right? Okay, and thus we can see the evaluation and the analysis. The development system evaluation consists of, okay, the one is testing accuracy of detecting the use mass temperature calibration, evaluation sensor to temperature measure nose and eye detection, the calibration of the MLX 90614 temperature sensor with Y highway main one thermometer gun using polynomial approach. Okay, and we can see the evaluation about the ultrasonic sensor. We can see of the distance one, the range is 10 until 13 is detected and the action will be execute the face detection. And if the range is more than 30, if we can undetected and keep measuring distance from the ultrasonic sensor. And we can see based on the result test we have carried out the result of the engine, it can be said this ultrasonic sensor able to work well, okay, by conducting experiment on several distance sample. Okay, the ultrasonic sensor can be detect objects that are less than 30 centimeter. Next is MLX calibration. This is the some non-linear data I have. Do from the calibration the highway mean 1 to calibration the MLX to have the same the same the same um, the same temperature. Okay, then the approach may be masking scatter free. To facilitate the approach, the trendline analysis is carried out using polynomial approach because the polynomial has not many error result and is quite close to the original data. Okay, this is the graph of the polynomial approach, and we can see about the Huawei and MLX, and we get the formula is this. You guys can see. Okay, after that, this data after calibration and have the error. This calibration is like a plastic box from 428.99 to 30 to 33.37, something like that. From the result of the data using polynomial approach has error not too large, namely maximum is 1.63 Celsius. That is the maximum error data. And yeah, you can see this. The total error is from to this 3. The total error is 38.81. And this is the evaluation about the camera Raspberry Pi. You can see this properly using mask is detected, not detected. If the condition is not using mask, ice is detected and nose is not detected, and not using properly, ice is detected and nose. Oh, sorry. Okay, sorry. This is nose is detected from the not using mask, and not using properly is nose still detected. Sorry about this problem. You can see this in the image I have captured from the another condition. Okay, the next is implementation about the result system at shop for 3 days. Okay, you can see this about the condition is true positive ice. You can see the condition here. We get the data from the true positive ice is 76. Okay, the second one is three true positive nose. You can see the data is we get 84. Yeah, there is the the other condition. This is the graphic of the result system at shop 3 days to help you guys see about this condition. This is the graph of the graphic result system. And from this, you can see this node is berhasil is a success and gagal is a fail. You can see from the result as the expression that has been done. It's been found egg 1, egg 100 and 16 detection result has been obtained by the tool, and success rate to the tool algorithm is 70.38% of the data that successfully detect temperature and mass. And the data is taken from the number of detected ice data, detected nose, max population detected, and the temperature detected. Then there are two two yeah to 9.6662% of the data of the valid data max and the temperature. The data were updated from the number of mass population that were not detected, the wrong eye was detected, the wrong nose was detected, and the eye was not detected, and the wrong nose was undetected. Okay, this result is from this graph and this table. Okay, its conclusion. The conclusion is the result of testing implementation of the tool in store for 3 days got 816 detection result, which is 575 or this detection. A success is detection temperature of mass, and 242 detection result failed to detect temperature and mass. Okay, the second conclusion is the sensor that have been used in the IoT healthy protocol system are made capability as not using Hierarchy classifier algorithm and detecting of the temperature. This is based on testing carrier of the sensor, and the ultrasonic sensor are used to trigger the start program detection of health protocol if the object is distant less than 30 centimeter. And then this MLX about the temperature sensor can detect temperature of object have been calibrated to the large error rate a 1.63 Celsius. Okay, the Raspberry Pi Zero is used to help protocol system program to manage data received by sensor. This is advanced by the response speed of the tool is receive data from the ultrasonic sensor, which will the carry of the nose, eye, and temperature sensor detection with time range 4 until 5 seconds, as well as recording JSON data, and the probable delay is 1 second for the redetection. Okay, and website-based health protocol information system is built to can monitor detection result to can view detection history of the healthy protocol system, and about the information system access the events of the device request network, device response, and amount data store, the time required network. So defines in distance 5 centimeter. The range is 5 centimeter until 20 centimeter, and the 331 data can be accessed within 5 until 10 seconds. Okay, maybe about that my presentation, and thank you. That's for me. If you guys want to see my profile, you can check on this YouTube discussion. Okay, thank you.